welcome to our talk about precision farming. I'm going to keep you on our journey, like what we discovered by implementing a precision farming device. You see over there the Treescout. That's a device we're delivering to all kinds of apple growers. And it was a nice ride to bring such a product alive. So that's why we are here to tell you that. But we first start with quickly introducing ourselves.
Yeah, so I'm Sebastian. I'm one of the senior software engineers at Aurea, working on the Treescout project for the last 2 years and some change, with Aurea for 4 years. Originally from Canada and now inhabiting the Netherlands.
Yeah, I'm Wieneke Keller, the CTO of Aurea Imaging, so a part of the technology team, of course. But it's not a journey of only me and Sebastian. So over there is a picture of the team. I hope you can see it a little bit. It's a nice picture that really shows who we are, because if you look carefully, you see that all our feet are covered in mud. We are an agriculture company, so everyone needs to go to the field and get their feet dirty and really be in the ground. This was during a team event. It was a typical Dutch event, Watlopen. I don't know if you're familiar with it, but sometimes the sea is very low in the north of the Netherlands. You can walk there and then you get that kind of seats. And special attention to a guy in the middle, Navneet. He's our machine learning engineer. He couldn't join, but part of the story he was really important for, so I thought let's mention him. And I know it's a tech conference, Berlin Buzzword, and you learned a lot about LLMs and other things, but I'm going to first learn you something totally different, because I think it's important that you really understand who our customers are. So, become an apple grower in 5 minutes. It's just shortly, but after those 5 minutes, you can be an apple grower. So the first question is, which apple is the best? Do you know? Well, it's actually the middle one. As an apple grower, you want to get the most value out of your apples. And consumers and supermarkets want to have evenly sized apples from a very specific size. So I don't know if you ever notice it in the supermarket, but all the apples are the same size. Well, that's not how trees usually grow apples. And for a grower, it makes 40 cents of a difference per kilogram if the apple is in that right size class. And it's really like half a centimeter difference, make that kind of a different shit. So they really want to have the best size apples. Next question, which is really important for an apple grower. Which tree is the best? What do you think? Well, it's somewhere in the middle. To get that optimal size of apples, if you are the apple trees, they have a fixed amount of energy to put in leaves, apples, and blossom. So if you have many blossom, probably the apples will be small. If you so if you have lots of blossom, small apples, not that much blossom, big apples. So there is kind of an optimum number of blossoms, which gives you the right apples. So with that knowledge, we came actually to the mission of our company, and that's unlocking the potential of every tree. So our founders found out they were already in that business, and there is a huge value in optimizing on tree level instead of on field level. And it's not only benefiting the yield, but also minimizing chemicals, minimizing fertilizers, really make sure that, with the right with the right chemicals, having the right results. So for this talk, we will focus on one specific use case, and that is blossom thinning. That's why I introduced that quickly. We also do other things with growth regulation and fruit counting. But the blossom thinning case is by far the most interesting, because as you understand, blossom is not that very often in a year. It's only once a year for 2 weeks. So it makes our use case even more challenging, because we are in a very specific time period. Well, so with all this knowledge and this vision, what were we planning to build? So this is a kind of an overview. It's the sketch where we started with this product. So we were thinking, okay, if you put a device on top of the tractor which scans all the trees, we put some machine learning models which are running on that device. Then you can detect all nice characteristics of the tree. And then you can make an overview of which tree has lots of blossom and which don't have. So we decided to make a device. You see it over there. We call it the Treescout. It's relatively straightforward. So we bought some we just use commonly available hardware. So there are 2 stereo cameras in it. There's a syslogic to do onboard processing, and some components to integrate with the tractor ecosystem. So you see there the little UI, which is not that advanced, but most of the growers already have that in their tractor. And in the SysLogic is, of course, also a modem, so we can connect to the internet. And we also integrate with precision GPS. So many growers already have precision GPS on their tractor for other purposes. And we are integrating with that so that when we do our object detection, we can actually know precise where the object is in the world. So we have kind of a lot of geodata. And well, then ideally, how would the process look like if we have built all this software and everything for the grower from his perspective? It would look like more or less like this. He's driving through his orchard, turns on the Treescout, collects all the data. We're uploading that to the cloud. There we have a nice portal. And you see like the squares, like the green squares are lots of blossom and the red squares are not many blossom. And it's especially on tree level. When he has that map, he can decide which trees he wants to spray or not. Get that map out of the portal, put it in the sprayer. You think, well, that sounds very manual, but that's the agriculture, you know. So we like to integrate, but it's just that the sprayers need a USB stick with a file on it. But we facilitate to bringing that file to the sprayer, and then he will spray, and the sprayer will go on based on our map and the threshold. So it goes on and off based on where he is in the field on the precision GPS. Well, and then you have that optimal size apples later on in the year. So really cool. So we were quite optimistic and start building the hardware, the software. But first, you need to start, of course, before you can map the blossom to a tree. The first step is that you need to know where the tree is. So that was when we were trying the first beta product in 2023. That was our first challenge. Detecting all the trees, because when you know where the trees are, then you can later on tell on which tree the blossom is, where the apples are on. So we did a good attempt, and well, these are some of the results of the first year. So what you see in the first picture is a GPS track. It's a GPS track of collected by our Treescout, so that was the good thing. It was actually integrating with the GPS, but you see that it's not really a straight line. And I know the one who was driving the tractor, and I called him, what was you doing? You know, you need to drive straight. And he said, I was driving very straight. I didn't drag anything. So yeah, the question was, what was happening? Why was the tractor going straight? And did we get that kind of results? The other strange thing we were seeing was the other picture, like the white spots, are where the trees actually are. We manually went to the fields to collect the data. And the red points are what the system was detecting. Yeah, the good news is we were detecting something, and there was a pattern. Yeah, but it didn't make any sense. So the first season, yeah, we had 8 customers. We did put lots of effort in it, only very limited results. It took a month. And as I said, Blossom is 2 weeks, so it was absolutely useless, those data. We had no clue how to fix incidents, because, yeah, it was something went wrong, and it could be the GPS, our edge processing, the cloud processing, could be somewhere, we couldn't find out where. And, yeah, so the customer support was kind of panic. Actually, it were the software engineers who did the support. And this was quite a challenging period. So we were really realizing this is not a sustainable way how we can get it actually production ready. So that was where where we need to really rethink our setup. So how can we make sure that this will be a success?
And that's about where I come in. Excuse me. So I came into the project basically right after this, about 2 years ago. And very quickly, we identified sort of where the challenge, or had to identify where the challenges were in the existing implementation. So I came in basically right after this. I'd watched where the team was struggling already, and I was brought in to, figure out where to go from here. And I'm going to take you through basically that journey over the past couple of years. So to start with, Wieneke's already given you kind of the commercial side. Let's dive into the tech a little. You're at a search conference, so of course I'm going to teach you about automotive programming. So yes, obviously, it's attached to a vehicle. It runs off, actually, the tractor's electrical system. Who here has any kind of use case where your only shutdown mode of any kind is hard power cut? Imagine what that'll do to any kind of software, let alone something that needs persistence, like your database. Not fun. We're working in a closed standards ecosystem. All of the GPS standards, most of the GPS standards we work with are actually closed source. No open source implementations or libraries, a bit of reverse engineering, but a lot of it we've got to figure out from scratch and try not to get sued in the process. We're not a hardware company either. We're still a software company. We're an agronomics company. So we're integrating all sorts of complex third-party dependencies, both from the actual hardware vendors and, of course, everybody's favorite people in the open source ecosystem, NVIDIA. Because you think your NVIDIA dependencies are bad for your little Jupyter notebook? Try their stuff for edge devices and for ARM. You'll never think twice about Jupyter notebooks again. So, about 2 years ago, our software architecture for the device side looked like this. It was basically single Python service broken up into about 4 or 5 pseudo microservices based on the multiprocessing library. For those who don't know, multiprocessing is Python's fork and spawn implementation. All running inside a single Docker container on board the edge device, which is basically a ruggedized NVIDIA Jetson made by a company called SysLogic. We had a watchdog process that would basically restart other components when they failed. Problem is, who watches the watchers? When the watchdog failed, everything would die anyways. Because it was all based on Unix pipes, they still couldn't reestablish connection. The watchdog would bring the service back up. It still couldn't talk to anything else. Things still didn't work. And the whole thing, there were a lot of unrelated components talking to each other. Because it was all one big code base, it was very easy to connect things that shouldn't have been. And the result of that was what you saw a couple slides ago. During the season, it was chaos, panic, and disorder. And after the season, we had to have a big, long think about, hey, where do we go from here? And that basically led us to one of 2 options. The first was, let's call it the conventional approach. Those who've done embedded edge programming before will recognize Robot Operating System, or ROS, now available for both C++ and Python, but historically mostly targeting C++. And that was one of the options we very seriously looked at. But the other option we looked at was rather more radical. It was actually Kubernetes. On board the tractor, right there on the edge. And that is ultimately what we went with. And the reason for that was we estimated it would take about 1.5 years to bring our system up to its previous state if we were to rebuild it with ROS. With Kubernetes, we did it in 4 months. And we were able to recycle a lot more of what we'd already had. And we could already see that just during the evaluation process, that with ROS, we'd have to teach the whole team C++, who are all Python programmers, mostly from a GIS and machine learning background. Whereas with Kubernetes, with Docker, we could keep doing what we're doing, keep building Python stuff. We already had a deep knowledge of Kubernetes within the company from our cloud infrastructure, so that was, in fact, what we went with. And that brings us to where we are today. I mean, should look kind of familiar. Whole bunch of Docker containers running, 8 true microservices, each broken up into between 1 and 4 deployments. Some of them even have a bit of limited horizontal scaling to overcome, let's say, concurrency problems. We use RabbitMQ and HTTP for inter-process communication, so never any question of communication breakdown. If a pod dies, it just starts back up, rejoins the RabbitMQ, and keeps slurping from the queue. And everything's nice and well separated. Nice CI pipeline over everything. And this is what our stack looks like today. Python everywhere, Kubernetes everywhere. On the edge, we're using TensorRT for running our machine vision. I'll get into that in a bit more detail later. And we especially and a big part of how this has succeeded as well is we take that philosophy of stack ultramodernism, okay, I need to rephrase that later, to every corner of our stack. There is no part of our software that runs any Python version lower than 3.12. Most actually runs 3.13, apart from a couple cases where we have dependency issues. And we adopt the latest and greatest tooling basically as it becomes available. For instance, we were early adopters of UV back in about September of last year. So that brings us to today.
Yeah. So then it was 2024, and as you can imagine, that we decided to just sell the product before we could actually test it in the field, because we're a startup. So yeah, and the season comes when it comes, so you can't wait for it. But we deployed it in production. We decided to stay with more or less the same devices because we were still a little bit scared about last year. But it worked out pretty well. So we did have kind of 85 maps. You can imagine that each grower has somewhere between the 10 and 30 fields. And I mean, with the results that it's one field which an actionable map is coming out. So that was quite good, like in 1 or 2 weeks. And what was really cool is that it was available within 1 hour the first year. So we actually kind of impressed the grower as well. Wow, this is really working very well. But I think the major thing was that we were actually able to solve issues. There were many issues. It's still like in an outdoor environment, integrating with so many parties, it's like just challenging. But at least, hey, we were able to fix that. So that's fine. We are trying to learn. So that was really cool. And the customer support was, but yeah, it was okay. It was still with the development team because they know the best how it works. So with that success, our sales department said, well, let's scale even further. Next year, 40 devices. So do it times 5. So that was this May, so it's pretty new information, but also that went relatively well. The only thing is that now the time to insight increased to 24 hours, so we need to reevaluate some of our architectural choices to get it back, but it was still fine because that was what we promised customers. And we now also included an operations team, which can actually support the device, so we built some tooling around to do that. So until now quite successful, and we are now planning to scale to 100 devices next year, so new challenges are ahead of us. And to give you a little bit of an idea of how it looks like, blossom thinning, I brought a small video. What you see over here is a 3-row sprayer, and this farmer put some blue light on the liquid they're putting on, and you see that it goes on and off based on the blossom. So the map we made with our Treescout was imported in the sprayer, and then it's executing it on this level. And with this liquid, half of the blossoms just dries. It's kind of a salty solution which they spray on it. And the cool thing is this was made by the son of a grower who likes drones, and they are so proud of using it that they're actually sending us the whole day pictures of, hey, look, I'm in my tractor driving your thing. Look, with my drone I made this image. So it's really cool to see how they really embrace our product. So that was quite good.
Of course, not everything goes according to plan. These are some raw images, unedited, from a drive a customer did last year. For those who don't know, in agriculture, the root of the tree goes at the bottom. Oh, come on. One of our developers, who shall remain nameless, except that I'm wearing his underwear, managed to submit a bug in a last-minute PR. This bug made it onto a couple of customer devices, because we have over-the-air updates. And the customer went and drove his field and found that, yes, all the images were upside down and backwards. However, because we have this Docker-based, Kubernetes-based, over-the-air kind of architecture, we were actually able to find the bug, fix the bug, and deploy a fix to the customer's site all within a few hours. And he actually successfully redrove his field later that day and got good results out of it. So, with all of that, what did we learn by this? Well, for starters, I kind of alluded to this earlier, play to your team's strengths. We're not an embedded company, we're not an edge company, we're not an automotive company. We are a data science, cloud native, agronomics kind, like machine vision kind of company. So, we chose a stack, we went with a set of tools that, while deeply unconventional for the application, very much played to what we're already good at. And because it's, the 2020s, you actually have those options now in a way that you might not have had, let's say, 10 years ago. Unfortunately, Python. Those of us those here who build Python software, let's say for the cloud, for your backend, you all know this very well. Concurrency stinks. That was actually our big scaling limitation during the most recent Blossom season, the one that caused us to nearly bust our SLAs, was our cloud backend couldn't keep up with the load. The database was fine, all the underlying stuff was fine. We couldn't scale it fast enough to actually keep up with some of the analytics. A lot of the data loading was CPU bound rather than IO bound because it's geodata, you need to package it in certain ways for actual transmission across the wire. We're still working on that part, I'll admit. We have some plans for later this year on our roadmap to actually massively improve the scalability of our data architecture to support our scaling plans for 2026 and beyond. Most notably, rather than actually storing it as just ordinary data in database, we're actually probably going to be using Parquet files, so a modern geofile format in a cloud storage bucket. TensorRT. So Who here knows TensorRT? Who here does machine vision? Okay, nobody, fine. Well, okay, one guy, kind of. So TensorRT is a model representation / runtime. Basically, the idea is it's a universal model representation. You take your model from whatever format you generated in, we use PyTorch, and then you convert it to this alternative representation that's better optimized for your target hardware. What this has enabled for us is the model in PyTorch representation being run through Ultralytics, it's a YOLO model, takes about 22 milliseconds to do object detection on our image. Through TensorRT, it takes about 6.7, which sounds great, right? 70% increase in performance for no cost. That's not quite the case, though. With TensorRT, you really need to build for your target hardware, build your model representation artifact for your target hardware, for your target application. If you screw up, it doesn't work or it gives poor results, and it's not very clear why it does that. These two maps are actually great evidence. The map you see on my right, your left, is what happened when we got it wrong. The model had been trained on 1080p data, but there was a transformation layer that was downsampling it to VGA, I think, SVGA resolution. The result of which was the model was performing actually very poorly. When we realized that and fixed it, we got the other map, the one with lots of green. That's actually far more representative of the real-world data set. The farmer didn't drive the whole field, that's why there's a big gap in it, but that was actually a lot closer to reality. But it took us a while to figure out what was going on. And this really pointed to us the need to have a proper, really mature CI and MLOps pipeline around this stuff to ensure that the artifact we were getting was actually the artifact we were expecting. And this actually holds true for a lot of this stuff. Now, everybody knows the NVIDIA Dragon. Everybody's wrestled with NVIDIA's dependencies at some point or another, right? At least anyone who does CUDA. Or any kind of machine learning, machine vision. You can tame the beast. NVIDIA's dependencies for their Jetson platform are much more cantankerous than those for, than those for, let's say, ordinary desktop, ordinary AMD 64 Linux. They ship a whole operating system distribution meant specifically for the hardware platform, which is great, except when you realize that even their second to most recent version, which only went out of support this year, only supports Python 3.8. So yeah, imagine trying to write modern software for such a stack. But again, you can actually defeat this. The only reason for the old Python support was because a lot of the libraries were only compiled against Python 3.8. Good news is, if you have a robust enough CI environment and CI philosophy, you can actually recompile them yourself for your targets. And while we're still working on totally taming the dragon, by the end of this year, we expect that we'll have solved all of our NVIDIA issues using both a combination of, robust CI, but also tooling from the Kubernetes ecosystem to enable things like in-place operating system updates. Something that right now isn't possible. Right now, if you want to update our operating system, you have to go out with a laptop and a USB cable and actually reflash it from the outside. Not fun. Not when your devices are scattered across half of Europe in farmers' fields. But it is possible to get there, and we are, in fact, getting there. And that kind of takes us to, where do we go from here? Like I already kind of alluded to, keeping the system up to date. We have the ability to distribute over-the-air updates for anything inside the Kubernetes cluster, using just ordinary Kubernetes tooling. Hooray! The operating system we're still working on. We're using a tool called K3s, which is basically a containerized operating system, really, OS in a box. You have a couple partitions it switches back and forth on, so you can actually do atomic in-place OS updates, really cool stuff actually, to enable in-place over-the-air OS updates. Not zero downtime, because that's not really possible, but as close to zero downtime as it's possible to get it. Basically, all it is a device reboot at the end. We're also working on improving our hardware setup. Right now, we've got a couple cameras and fixed mounts. That's not always great. We have problems supporting, for instance, trees that are higher than a certain height because the top of the tree is actually above the field of vision. We're working on all sorts of new geodata analytics. Right now, we've got, in the best cases, 2 to 3 years worth of data. When we start having 4, 5, 10 years of data, we can actually give the farmer all sorts of historical insights, what parts of the field are doing well, what parts of the field are doing poorly. And we believe there's tremendous value in that for the grower. And yeah, as Wieneke and I again already alluded to, improving our fleet size. Right now we have 40 devices in a few countries. Next year we want to more than double that. And agriculture is a worldwide business. This is going to be running, maybe not 24/7, but for good chunks of the year, day and night. And we have to be ready for that. And that basically about wraps it up. So if you've got any questions, comments, sarcastic insults, now's your chance. And yes, we are hiring.
Amazing. So, I mean, I am impressed with your talk at multiple levels, but I would give our audience some opportunity to ask questions. Anyone?
Don't be shy.
Yeah, don't be shy. While I love the aspect that you brought in about, number one, growth of your scale, your business, and the response time, I think I have been absolutely amazed with that because that shows real improvement and real learning. I think that table summarizes pretty much everything that I could have expected. I mean, that's as realistic as it can get. So definitely applause to that. And I learned today, so TIL, the TensorRT, definitely going to look that up as well. Mm-hmm. So we still have time for questions. If somebody's been brewing on, we have a question.
So I'd be interested in basically how do you know your own accuracy, right? If your tractor now drives through the field and you get those images and later spray the plants, right? How do you know whether you've sprayed the right amount, whether you've counted the right amount of blossoms and so on? Like how do you?
Yeah, I can answer on that. It's lots of manual labor at the moment. So to have to validate accuracy, we just go first to the field, actually count blossom manually. Measure the vigor of a tree, measure with a GPS stick where the tree is, and then we're just running our Treescout and then validating how it is. We do want to do also more on automated machine learning model statistics so that you see if there's model drift or if there's anything going on. But for now, it's manual work. And even sometimes growers are calling us, hey, I don't trust your map. You know, they're critical customers. Then we just go there with our GPS stick.
Again?
Oh, okay. Well, it is a
whatever.
Q&A. We just go there with the stick with our counting to convince him that it's actually accurate. But there are some challenges still because we, for example, for the positions of the tree, we first aimed for 80% is on the right position. And then you have the discussion. Is it that you then from the 10 trees see 8 of them? Or can they be off in 80% for 20 centimeters? And we're still discovering a little bit what we are able to and what our consumers think is good enough.
I will note also that it's still early days for a lot of the machine learning, a lot of the machine vision stuff. A lot of the focus up to this point has been just getting the system working reliably as sort of a platform for the detection, for the computer vision stuff, for the positioning. And we've got a lot of stuff in the pipeline for, improving exactly that, improving accuracy and precision.
Cool, thanks.
Anybody else?
Questions? I think I'm interested to know about. So we've spoken a lot about the fruits and everything pretty much about the fruit. But I think there's definitely like a significance that a soil also has. Are you already doing that? Like discovering about the health of the soil? How do we enrich it to kind of get the maximum bloom? Have you been doing that already? Or
well, we had a small pilot with that to map. There is another company who is doing a great job on soil mapping. And in the end, it will be really great to integrate that data. But we're focusing on what you can see. And you can't see much from the soil. Maybe we can, but for now we think that measuring soil is more effective as looking to it. But we're definitely looking into combining all those different data sources. Also, weather data would be really interesting to include.
Absolutely, absolutely. Which is this other company that is doing or capturing data?
Oh, I forgot the name. The soil data. Yeah, it's also a small startup. It's one of our neighboring companies in that area.
No problem. Okay, so I guess that was amazing talk, and definitely like the aspect I didn't think about covering at buzzwords. Like you've got me interested about crops and like fruits and many different things. So thanks to you for that. And I guess that definitely deserves a big, huge round of applause. People, thank you. Thank you so much.